Hi, I'm Maria Nadestad. A question that I often get, especially from colleagues, is should I do a PhD? And the knee-jerk reaction that I often hear from other people, and I've also given this myself, is no, don't. But that was when I was just out of my own PhD, which is very hard to do. Mine wasn't hard in comparison to many other experiences that I have heard from people, but it's still somewhat of an almost traumatic experience, no matter how good your advisor is and like how well you do in it, like it's still gonna be hard. So knee-jerk reaction can be no, but let's dig a little bit deeper into that and we'll see that the answer is basically a qualified yes. But let's talk about it. So here I'm going to talk mostly about a bioinformatics PhD. So everything I say, just assume that I'm talking bioinformatics PhD and not any other field. Some things that I say may apply outside the scope of bioinformatics, but please don't assume that it does. What I try to do with these videos is give you advice that I would give my friends or colleagues. So take it as one perspective, and if you have any other people that you can ask who have done PhDs, or people who are in industry and have not done PhDs, and so on, you get all those perspectives and use that to help you make your own decision. I'm just someone who might be a few years ahead of you on a similar career path, and so take it from that point of view. All right, so I'll give you my background real quick. I did a PhD right after college where I had majored in biology, and my PhD was in bioinformatics/genomics. Back when I was still doing my bachelor's in biology, I did actually look for jobs and I didn't find anything that was interesting. I needed to know cell culture in order to even get a temp job with a biology degree, at least from what I looked at, but I didn't look very thoroughly. If I had done computer science as my bachelor's degree, I probably would have been able to get and would have taken a job straight in industry. But with biology, my options were more slim, and that meant that I ended up doing a PhD right after college. I think this was the right decision for me, but it's not going to be the right decision for everyone. I just want to let you know that there is a difference depending on whether you come from biology or CS in what you can do with just a bachelor's. Okay, so there are two things that you get from doing a PhD. Two major categories of things, at least. One of them is the degree itself, where you can say, I have a PhD, it goes on your resume, and you can use it to get jobs. The other thing is what you actually learn and what you actually get out of it. So first, on the degree side, is the most important thing to know here is that a PhD is necessary but not sufficient to become a professor. And here we're talking about a professor who does either teaching or research at a normal university or research institution that is more of an academic style. Again, I say necessary, but it's not sufficient because it is very hard to become a professor. I'll mention a bit on that in a minute. But that's like the main reason you should clearly do a PhD is if you want to be a professor for sure, then you should definitely do a PhD. A PhD can also really help if you want to do research in industry, especially if you want to really rise up that ladder and lead a research effort with multiple people. And if you want to be managing other researchers, they're generally going to be PhDs. And most companies are not going to let you have that role if you're not a PhD yourself. From my perspective, I have seen a lot more people with a bachelor's or a master's hit a ceiling where they don't feel like they can rise in their research careers, even in like biotech companies that are not primarily research focused. They can still kind of hit a ceiling because they don't have a PhD. So that's another thing to know. The degree is not going to be necessary. A PhD is not necessary if you're happy basically doing analysis work or coding, like being on a software engineering team, and you don't care enough about research to choose the research direction, or to be the person like reading papers and deciding what should we go and research next. So basically, PhD and research are very tightly connected, and that's how you should think of it. And that goes for basically any field, not just bioinformatics, actually. Okay, so one of the things you get out of a PhD is the degree. The other thing is what you actually learn from it and how you as a human being and as a professional develop from it. Some of the big things there is you learn to be independent, to take initiative in your own projects, to really own your PhD research project for yourself. And if you're only following what other people say, then you can quickly learn that they don't have to live with the consequences of the choices that you make. And so blindly following their advice may not actually be a good idea. And the same thing goes for this video. You should absolutely make your own choices and educate yourself as much as possible. I'm just doing this to help provide some perspective and hopefully help you think through a few more issues that you might not have thought about before, so that you can go and find other people who can also talk to you about these things, or you can go and look it up online and just talk to more people. So anyway, another thing you really learn is resourcefulness. There are a lot of things that are really hard in science, and when you're doing research, you will discover that, for instance, there isn't an aligner that works with the kind of data that you have, or that you don't have the right kind of visualization that you want to use. It just doesn't exist yet, and maybe you need to create it. There's a lot of things when you're at the cutting edge that are just not as polished as most of the kinds of applications that you normally use in work. When you're at the cutting edge in science, you will constantly bump up against things that just don't exist yet. And you have to decide, do I make them? Do I write a whole paper on just how to solve this one issue? Or do I keep my eyes focused on the larger prize of the science I'm trying to do? There's a lot of really interesting things. And I know from my case in my research, I ended up taking a few of those tangents and being there isn't a good visualization software for long reads. I'm gonna make one. That one's called Ribbon. And there's all these different things where I just decided I'm gonna make something to solve this problem. But you can also just keep going with the science and try to weave around those issues. Either way, you have to be very resourceful when you're doing scientific research, because at the cutting edge, nothing is polished yet. Another thing that you learn to do is going deep and becoming an expert in a subject. The goal for you should be to be enough of an expert on the things that you're working on that by the time you give your thesis defense, most of your committee is just going to be learning about this for the first time. They're not gonna, they're gonna have interesting questions for you, but you'll know how to answer all of them. It's not gonna be something where they're more of an expert on it than you are. That's impossible. You just spent 4 years and sometimes more deep into this topic. You will know it very well. If you don't, then start doing that. You should absolutely get deep into the topic. And that's what you do in a PhD. You should absolutely be becoming an expert on the topic. And that's something that you have time to do in a PhD. It may not seem like you do, but try to do that work up front. When you do get into the PhD, try to actually go deep in the topic before you start trying to solve all the problems, because you'll have a better idea of what the problems are to solve if you read deep in the literature first. I, in some ways, did not do this enough at the beginning and had to kind of catch up on that later. So independence goes along with also taking initiative. You really need to be taking ownership of a project, and that's something that you may be learning to do for the first time. It's something that I think I could have learned in industry as well without doing a PhD, and I think it's something that just comes with experience. But with a PhD, you get given more responsibility much sooner. And no one is just going to be, telling you what to do all the time. You're basically going to have to take initiative. And once you do that, you start liking it. At least I did. And my friends did. And we start taking more initiative from then on in our careers. And we end up doing much more interesting work. And we end up being more creative. And so that's been a good thing for me personally, at least. Another thing that's not really something that you learn, but I still wanted to include it here, is you get to present at conferences, and you get to do collaborations with other scientists. This means that you have like a great learning experience, but you also get to build a network that helps you get future jobs. All the jobs that I've had since graduate school, since doing my PhD, have been because of collaborations that I did and talks that I gave and conversations I had afterwards. It's entirely just based on like connections with other people. And when you're in a really niche field, like anything you're doing a PhD on, you need to get to know other people in that field to really kind of be able to get interesting opportunities after you're done with the PhD. Okay, so some downsides of a PhD. On the academic side, becoming a professor is very hard. Finding faculty jobs, it's very competitive. It's very hard to get a faculty job. You will not usually be able to go straight from a PhD to a faculty job. You will usually have to do at least one postdoc, if not more, in between. And this can take anywhere from 1 to 5 years, maybe more. So include that in your calculations, please, if you actually want to be a professor. But there's always industry jobs, and you don't need postdocs for that. So just think about that if you want to be a professor, especially. Also, a thing for faculty jobs is the chances are, even with a lot of luck and hard work, it's hard getting a faculty job in the first place. But even if you do, you're not necessarily going to be in your favorite city, such as the city that you and your spouse are already living in and where your spouse really likes their job. You may have to move, and you may have to move not only for, like, you might have to move first for your PhD, and then to a different city for your postdoc, and then to a different city for your first faculty appointment. Then you usually stay at your first faculty appointment for several years, but then you might get the opportunity to go to an even better school or something, so then you might move again later. That's if your career really goes well, but you can also just like stay at that first place forever. It just means that you're at least moving PhD, postdoc, and faculty position. It's okay to stay in the same school, but chances are you're usually not going to be able to just get a faculty job in your favorite city. It's very hard to get faculty jobs. There are not a lot of job openings. So keep that in mind. On the industry side, for myself and a few other people who have PhDs in genomics, bioinformatics type fields, we sometimes find that we end up working at a biotech company, and there are other people that we're working with who don't have PhDs but have essentially the same job right now. Now, I still think that in the future, they might hit a ceiling if they try to become the head of that department or something, and then I'll get the opportunity instead because I have a PhD, which doesn't really make sense because at that point they have the same amount of experience that I do. And I don't think that's necessarily fair, but it's something to be aware of. Now, the problem with that as someone who does have a PhD is that there's also this other department where there are software engineers, and sometimes those software engineers have no graduate degree, but they still make more money than the PhD bioinformaticians, and that bothered me when I first started out in industry, especially because I was also doing software engineering work. So that's something to be aware of. In general, if you are kind of starting out and you have software skills and you're kind of more interested in making a lot of money with those software skills, by all means, just like go get a job at Facebook or Google or, any of those companies, and don't worry about doing a PhD or any of that hard stuff. Anyway, I have a whole video on how people from a CS background can move into bioinformatics, so be sure to check that out. But in general, for some of us who might be a little bit bothered by this, I just want to note that we might be making possibly a little bit less than the software engineers do, But we do get, in my opinion, to do more interesting work in the long term because we do get to work on research. And it is possible for us to make more money eventually as well. It's just a little bit harder. And of course, this is because I'm also in Silicon Valley, and so the standards for software engineers are like ridiculously high. But just something to mention, if you care about money, I always want to make sure that, I put those topics out there so you can look into it for yourself. Okay, so an important word on doing a master's versus a PhD. I need to tell you that I don't have a master's, but I do have friends and colleagues who do. So I have 3 things to say on the topic that mostly just come from a little bit of what I've experienced and a little bit of just like understanding how master's programs work and so on. But you should absolutely talk to someone who has a master's to learn more about masters if you are considering one. Don't just take my word for it. I have a limited view of this, but there are some topics here that I want to bring to your attention so you can go look it up for yourself or ask other people about it. Okay, so 3 things. Number 1, PhDs usually pay you a stipend, which is somewhere between $20,000 to $30,000 a year in the US, and it's not much, but it's enough for you to live on usually during the time that you're doing the PhD. On the other hand, for masters, you actually have to pay tuition and you don't get paid a stipend, which means that a PhD gives you money and a master's takes it away, at least initially. Of course, then you can finish a master's faster and get into the workforce. You can probably make up that difference in money fairly quickly. But I think it's important to know that with a PhD, you also end up with a PhD at the end. So that's a note on money again. These topics are important. This is your life. And so that was number 1. PhDs pay you and you pay for a master's. Number 2, when we talk about hitting a ceiling in your career where you kind of need a PhD in order to get that like head of research type job, or even like any kind of research job at many companies, and especially in academia, of course, a master's is not going to help you get above that barrier. It's not going to help you above the ceiling. You will actually need a PhD for that. So you can learn a lot by doing a master's, but since the degree doesn't get you past that barrier, that's something really important that you need to consider. So if you do want to do research eventually, you might want to consider just doing a PhD for that. I just want to mention that I have met people with master's degrees, and sometimes they're still considering I should probably do a PhD so that I can get above that ceiling still. All right, so the third thing is it's a common misconception that you need to have a master's before doing a PhD. And this is actually not true. In all the US bioinformatics PhD programs that I applied to, every single one that I was looking at, any that I've ever seen, that's not true. You don't need to do a master's first. In Europe, I think the standard is that you have to do a master's before doing a PhD. And then the PhD is also a little bit shorter than it is in the US, and so it kind of ends up being about the same, if not a little bit shorter overall. So that's something to think about. Europe is different. The rest of the world, I don't know. Google it, talk to people, please. But for the US at least, don't worry about doing a master's if you actually want to end up with a PhD at the end. So that's like the main thing. If you want to do research and you want a PhD eventually, don't do a master's as a first step. Try to actually apply to all the PhD programs that you're most interested in going to and see if you can just get into them now. All right, so I want to tell another story of someone doing a PhD. We already heard about mine a little bit, just going straight into a PhD from college. But here's another story on that. So a friend of mine she had gone into industry straight out of college because in college she had actually majored in something akin to bioinformatics or biomedical informatics, or one of those majors that actually combines biology and computer science and has like an actual bioinformatics type major. and she had done an internship at a company, and she really liked interning at that company and decided that she wanted to work at that company after she graduated college. So she did that. And then a few years into it, she was kind of starting to think, oh, maybe I should do a PhD. Now, this was great because by this time she already had several colleagues around her who had PhDs, and she could make sure that she was making the choice to do a PhD for the right reasons. She decided to do that, and she actually was able to leverage connections that she made by going to scientific conferences and knowing other people like myself and other people at the company who had research experience and knew people in academia as well, and she was able to get a really great spot in a PhD program that she was super excited about. And so this experience for her of being in industry for a few years ended up launching her into great opportunities for a PhD. And she had also had the chance to save up money for a few years, have some great experience. She had connections and experience doing research and analysis and so on, like coding and analysis type work, and working with bioinformatics data and so on. She already had all that great experience, and now she can use that in her PhD, which I think is just a great springboard. Like, she's able to be much more, she's able to onboard really quickly and become productive in her PhD much faster than I think people normally can, because she was able to get that experience initially. So that's also a good option. So overall, I would say that you should do a PhD if and only if you want to focus your career on research. Yeah, I hope that you come to a decision that you are happy with, and best of luck with your career. All right, bye.